I welcome all the students for this presentation. I am Professor S.R. Basavareddy from Mechanical Department. I am going to take the subject on Design of Machine Elements 1. That is for the 5th semester with the subject code 18ME52. This is one of the identified critical subject from the Mechanical Engineering Department, which involves mainly the numerical examples along with the theoretical part. The fundamental basic requirement for this subject starts from mechanics of material of the 3rd semester. That is a very basics requirement. So in this subject we mainly aim at finding out the various dimensions of a link of a mechanism for various forces involved or various forces acting on that particular component of the link. We are going to design that member based on the different criteria like strength, rigidity, functional aspect and the manufacturing requirements. These are the mainly important parameters of design. Then we are also going to consider here the various modes of failures which you have already studied in the 3rd semester mechanics of material subject. Then after designing the various different components, the student has to formulate a group of 4 students and then design a mini project in this particular subject. That is a basic requirement. So like other subject, this subject also has the 5 different modules. In the module 1, you are going to have the 2 chapters. The first chapter is a basic design process. Then you are going to have the various types of stresses involved based on the different type of forces acting on the link. Then you are going to have another chapter based on the design for static strength combined with the stress concentration effects. So here in the first part, you are going to have a small theoretical part, then followed by the basic steps that is followed for finding out various stress like normal stress, shear stress, compression stress, torsion stress, etc. And then on a link, there can be only one force at some time or there can be combination of forces. Combination forces are going to be like normal stress and shear stress that can act together. If 2 stresses are acting, then we have the concept of the theories of failure based on the principal stresses. So there we are going to find out the maximum of normal and shear stress, which we are going to call that is our combination or a resultant stress, which we call as a principal stress. Then we are going to have the mode circle also based on that. This is all things we have studied in the 3rd semester mechanics of material. So it is going to be like a revision here, but based on different types of examples. The examples are mainly concerned with the design aspect, meaning that we are going to find out the dimensions. So dimensions in the sense it can be a circular object which has a diameter d. What is the diameter size we are going to calculate? It can be a rectangular object, it can be a square object, it can be a solid, it can be hollow. So those component of a structure, we are going to find out the dimensions for the various forces subjected to. Then we are going to have design for a static strength, which meaning here is when the member is subjected to a static load, meaning that it is a gradually applied load, it is not an impact load on the member. If that is the case, we design the member for one particular load or otherwise for a combination of the load using the various theories of failures. We have a stress concentration here in the same chapter, which meaning is if a member is going to have a uniform cross section like this, the stress concentration effects are not going to be there. If a member is having a curvature, a small curvature or step down diameter, then we are going to have the stress concentration where the size changes. So that effects of stress concentration is going to produce more stresses at that particular point. Then the failure of the member may take place earlier. So therefore we are going to call that as a stress concentration. So elaborate on this aspects we will discuss whenever we come to the individual chapters. Then in the module 2, we are going to have the 2 chapters again. One is on the impact strength, another is based on the fatigue loading. Impact strength means we are going to find out the strength of the member which is subjected to impact load. That is going to be called as a suddenly applied load, otherwise it can be a shock type of load. So like in case of the riveting machines or otherwise a connecting rod of an engine we are going to have this kind of impact load applications. Then fatigue loading is meaning that whenever the load on the member changes cyclically with respect to time. That is, it can be from tensile load to compressive load with respect to time variation, or under the tensile load only it can vary the magnitude wise. So higher magnitude ones and lower magnitude ones, or higher ones to zero load. So the load magnitude changes, or same load cyclically it changes tensile to compression. So that change is done with respect to time. So this kind of load we are going to call as a fatigue loading. Okay, so these are the two chapters in this particular case. So we designed that member for different applications based on the impact load is one type of load and fatigue load is another type of load. Then we are going to have design of shafts. So this is a simple shaft what we are going to have, a solid circular shaft or it can be a hollow circular shaft. These are only two cross section what we are going to design here. When we say solid circular shaft, we find out what is going to be the outer diameter of that. If it is going to be hollow circular, we design or we find out dimensions of the outer diameter and inner diameter of the hollow shaft based on various types of loads. So in case of shafts, loads are going to be a torsion. So torsional load which we have studied in the mechanics metal earlier, the same load we are going to consider here. Otherwise, there can be bending loads. These are the two types of loads. So either torsion load is applied separately or bending load is applied separately, or it can be combination of torsion as well as a bending. So shear force bending moment diagrams we have studied in the third semester mechanics of material, and the pure torsional chapter also we have studied. So this chapter is going to be a little repetition of that, but with a different criteria of theories of failure, which we call as based on maximum normal stress theory and based on the maximum shear stress theory. So based on that, looking into the ASME code, means American Society of Mechanical Engineering, with reference to this code, we are going to design that particular shaft, means that we standardize the shaft. So here we are going to design the commercial shaft size. These shafts are used in the case of a power transmission. So power transmission, like in case of a headstock of a gear, headstock of a lathe, where we have the set of gears which are mounted on the shaft. So that is a power transmission shaft. Otherwise, you have seen in case of the automobile, the propeller shaft, and the below the chassis you find a propeller shaft. So that is going to be called as a power transmission shaft with hollow in nature. Then we compare whether shaft is having a advantage, hollow is shaft is advantage or solid shaft advantage based on the different criteria of design. Then in the same module, we have the design of keys and couplings. So keys is one of the important parameter for mounting the gear on the shaft, or mounting the coupling on the shaft, or mounting the clutch on the shaft. So this is a important element, so which is a small element, rectangular piece, which is going to take care of the power transmission. Likewise, coupling. Coupling also transmits the torque capability between the two parallel axes or between collinear axes, mainly used for the collinear axis shafts. Then in the module 4, we have three small chapters. One is called as design of permanent joints like riveted joints and welded joints. So this is a small theoretical part here, but riveted joint and welded joint are the two different chapters here. So riveted joint and welded joints are going to be called as a permanent type of joints. So riveted joint you have seen in case of the buses in particular, the entire chassis is made from aluminum sheet. These are being riveted. Likewise, rivets are used normally day to day in house utensil, cooker also we use the riveting arrangement, or we use the riveting arrangement in case of the ship building also. So there are many applications of the rivets are being used. So fan blades also you find rivets. So that is going to be called as a structural rivets for brackets. So in different applications we use the rivets. For the boiler applications also we use the rivets. Welded joints as is very familiar. Majority of you have seen the welded joints. You have done also welding in the workshop. So there is going to, you are going to design here. You have done the welding there earlier. Now you are going to design that welding here. Then in the fifth module, we are going to have the temporary joints like the quarter joint, knuckle joint, and the fasteners are going to be called as the temporary joints. Here we have also threaded fastener and a power screws. Threaded fasteners are nothing but are simple ordinary nut and bolts used for the power transmission, or it can be used for connecting the two members. Power screws are nothing but the screw thread used for transmission of the powers, like in case of a lead screw of a lathe, or it can be a screw jack, which is used in the automobile for lifting a vehicle up and down for removing the tires and all. So that is what we call as a screw jack. Then after studying all these five modules, university has recommended the assignment in particular. So assignment earlier we used to give you the module wise by the professors only, but now the assignment pattern is defined by the university. Means that your students are supposed to form a group of 4 students maximum to design the project. So these project design examples are specified by the faculty member. Student is supposed to design them with making a manual calculation. Then the drawings have to be done in the AutoCAD system using the software, using any modeling software. You have to draw the part drawing and assembly drawing. Then you have to submit a report, and that will have a credit in the internal assessment. So that is towards assignment. So there is no separate assignment we are giving in the form of writing the assignment in the pink book. So it will be done in the separate sheets. Then you are going to bind it and then going to submit it as the assignment format. So this is your complete syllabus. And from tomorrow I am going to start with, maybe next class I am going to start with individually the module number 1. But here for this case, in the subject design of machine elements 1. So this is the design of machine elements 1 in the 5th semester. Same subject, design of machine elements 2, will be there in the 6th semester. So this subject will have the 2 different semesters in 5th 1 and 6th 2. Okay. So this subject requires, there are many different textbooks are going to be there. So apart from that, I am going to give you the notes in particular, and you can use the soft copy of the notes for right now, and afterwards you can follow the once a regular contact classes starts, I am going to give you the notes for you to refer. So in this subject requires for you to refer the design data handbook. So this design data handbook is available in the college library as well as in the market. So this design data handbook, for like example, any one particular chapter if you take, what are the equations you are going to use and what are the tables you use to refer this, or otherwise you have the materials to be selected. So all these informations are available in the design data handbook. You are not going to by heart any equations here, but make a practice of referring to design data handbook for solving the examples under any particular chapter. So therefore, design data handbook is permitted in the IA test as well as for the final examination. So therefore, referring to the design data handbook equations under particular chapter, you can solve any kind of examples of a particular module. So that is very essential, which a student has to require to buy one design data handbook, which will be useful for 5th semester design 1 and 6th semester design 2. Okay. Otherwise, you find plenty of copies in the college library. So next session, I am going to start with directly module 1. So after this, thank you.